Hello everyone, welcome back to my channel. I hope you guys are doing great. Have you ever looked at a graph database and wondered how do people actually retrieve or update data inside it? Knowing what a graph database is and knowing how to work with one are two very different things. If you want to build AI applications using Neo4j knowledge graphs, Graph RAG recommendation systems, or intelligent search, then learning Cypher is one of the most valuable skills you can have. The good news is that Cypher is much easier to learn than most people expect. If you already know basic SQL, many concepts will feel familiar. Even if you have never worked with a database before, by the end of this video, you will understand the most important Cypher queries that every AI engineer should know. Let us begin with the most important idea. Cypher is the query language used by Neo4j. Just like SQL is used to work with relational databases, Cypher is used to work with graph databases. Instead of thinking about tables, rows, and columns, Cypher works with nodes and relationships. Imagine you are building an AI-powered learning platform. You have students, courses, instructors, and skills. Each of these can become a node. The connections between them become relationships. A student enrolls in a course. An instructor teaches a course. A course requires a particular skill. Cypher allows you to create, search, update, and delete all of these connections using a language that is designed specifically for graphs. One of the reasons developers enjoy using Cypher is because the syntax is highly visual. A node is represented using parentheses. For example, parentheses containing the word student represent a student node. Relationships are represented using arrows. An arrow from a student node to a course node with the label enrolled underscore in clearly shows the direction of the relationship. When you read a Cypher query, it almost looks like a diagram instead of code. Now let us understand the command that you will use more than any other. The match clause is used to find existing data inside the graph. Think of match as asking Neo4j, show me the nodes or relationships that satisfy this pattern. Suppose you want to find every student in your learning platform. You can write a query that matches all student nodes. Then you use return to display the results. Match finds the data. Return displays the data. These two clauses are usually used together. Now imagine your graph contains thousands of students, but you only want the student whose name is Rahul. This is where the where clause becomes useful. Where acts like a filter. First, match identifies all student nodes. Then, where keeps only those that satisfy the condition. Finally, return displays the filtered result. This approach is very similar to filtering records in SQL, but the syntax is much more natural because you are working with graph patterns. Now, let us move one step further. Finding nodes is useful, but graph databases become powerful when you start traversing relationships. Suppose you want to know which courses Rahul has enrolled in. Instead of joining multiple tables, you simply describe the relationship. You match the student node, follow the enrolled underscore in relationship, and reach the course node. The graph itself already knows how everything is connected. This is one of the biggest advantages of graph databases. The query describes the path rather than complicated joins. Now imagine you also want to know the instructor teaching those courses. Instead of writing multiple joins, you simply extend the graph pattern. From the course node, follow the teacher's relationship to the instructor node. The query grows naturally as your business problem grows. That is one of the reasons graph databases are so intuitive. Now you might be wondering how new data gets added. For that, we use create inserts entirely new nodes and relationships into the graph. Suppose a new course called Generative AI Fundamentals has been launched. You can create a course node with properties such as course name, duration, and difficulty level. Similarly, you can create a student node. Then you can create a relationship showing that the student has enrolled in that course. Everything becomes part of the graph. There is another important command that every AI engineer should know. It is called merge. Many beginners confuse create and merge. The difference is very important. Create always creates new data. If you execute the same create query 5 times, you will create 5 identical nodes. Merge behaves differently. Merge first checks whether the specified pattern already exists. If it exists, Neo4j uses the existing data. If it does not exist, Neo4j creates it. Imagine an enterprise knowledge base where thousands of documents reference the same technology. You certainly do not want hundreds of duplicate technology nodes. Merge helps maintain clean and consistent data. Whenever uniqueness matters, merge is usually the better choice. Now let us understand what properties are. Properties are simply information stored inside a node or relationship. A student node might contain properties such as name, age, email, and experience level. A course node might contain duration, category, rating, and language. Relationships can also have properties. For example, an enrolled underscore in relationship could store the enrollment date, completion status, or final score. This makes graph databases extremely expressive because both the objects and their connections can carry meaningful information. Sooner or later, you will need to modify existing data. That is where the asset clause comes into the picture. Asset is used to update properties. Suppose a student completes a course, you can update the completion status from false to true. Perhaps the student's skill level has improved. You can update that as well. Set allows you to modify existing information without recreating the node. Now let us talk about deleting data. Cypher provides the delete command. If a node no longer belongs in the graph, delete removes it. However, there is an important rule to remember. Neo4j does not allow you to delete a node if relationships are still connected to it. Why? Because removing the node while leaving relationships behind would create an invalid graph. If you want to remove both the node and every connected relationship, you use detach delete. This command safely removes the entire structure. That is the command most developers use in real-world applications. Now let us see how all these commands fit together in a practical workflow. Imagine a company is building an AI assistant for employee learning. A new employee joins the organization. The application creates the employee node. It creates the learning course. It connects the employee to the course. Later, the employee finishes the course. The application updates the completion status. If the course is discontinued, it removes the course along with its relationships. Almost every graph application follows a similar life cycle: create data, search data, update data, connect data, delete data when necessary. Once you understand these operations, you already know most of the Cypher commands used in day-to-day development. Now, before we wrap up, let us go through a few interview questions that are commonly asked. Here is the first question. What is the difference between create and merge? The answer is that create always inserts new data, while merge checks whether the specified node or relationship already exists before creating it. Merge helps prevent duplicated data. Now let us look at another question. Why is match considered the most important Cypher command? The answer is that match retrieves existing nodes and relationships from the graph. Almost every read operation begins with match. Here is another common interview question. Why does Neo4j require detach delete instead of delete in many situations? The answer is that nodes may have relationships connected to them. Detach delete removes both the node and all connected relationships safely, preventing an invalid graph structure. One more interview question. Why are relationships so important in graph databases? The answer is that relationships are first class citizens. They directly represent how data is connected, allowing graph traversal without expensive table joins. So, where does all of this matter for AI engineers? If you work with Neo4j, knowledge graphs, graph RAG, recommendation systems, enterprise search, fraud detection, or intelligent assistance, you will use Cypher regularly. Even if you are primarily a generative AI engineer, understanding Cypher allows you to retrieve structured knowledge efficiently and build more intelligent AI applications. Let us quickly summarize what we learned today. Cypher is the query language for Neo4j. Match retrieves existing data, return displays the results, where filters the data, create inserts, new nodes and relationships. Merge prevents duplicate data by reusing existing patterns whenever possible. Set updates, properties, delete removes nodes, detach, delete removes nodes together with their relationships. Properties store information inside nodes and relationships. Relationships represent the connections that make graph databases powerful. Imagine building an AI assistant that needs to understand how people, products, documents, and business knowledge are connected. Every recommendation, every search result, and every intelligent response depends on navigating those relationships efficiently. That is exactly where Cypher becomes an essential skill rather than just another query language. Thank you so much for watching. If you found this video helpful, please like the video, subscribe to Learn AI with Jay, and share it with someone who is starting their AI journey. Also, let me know in the comments which AI topic you would like me to cover next. Thank you for watching, and I will see you in the next video.